So hello everybody, welcome to my new live stream of Let's Talk AI. So welcome to our second episode. In today's live stream, we'll be talking about Grok 4.5, and actually Anthropic also released a new research paper. So we'll be also covering that. So let me know if my audio is clear. Let me just check it out. Let me see if my audio is clear. I hope it's good. Um, I hope the audio is okay. Um, if any of you have just joined the stream, please let me know. Alright, I think we are good. Let's just continue. So Anthropic, let's cover this research paper from Anthropic first. We'll be not reading the whole paper. This is the paper. So it's like, I don't know how many pages this is, but it's quite long. So we'll be not reading the whole thing, but maybe we'll make a separate live stream for this later. But let's just see if we are able to understand somewhat. Okay, you know what? Let's just ask Gemini to summarize it. Um, let's see all the highlights. We can give at least the highlights, right? Have you already read this research paper? Please let me know in the live chat if you have already. Alright, so I'm just skimming this research paper now. Okay, alright. I don't know why Gemini is just crashing. Let me see. Okay, alright, so that was it. Okay, so let me just read out the conclusion at least, the last part. Other results. What about consciousness? Okay, what's wrong with Gemini? Let me just refresh this page and see. Is Gemini not working? Not sure. Okay, let's just go through this fireship video first so that we get an idea about it. There is a fireship video. Let's just all right. Let's just go through this video. Okay.
Yesterday, Anthropic published a new paper claiming it found a bizarre global workspace hidden deep inside the brain of Claude, a place the model quietly thinks about things before it says them out loud. And that's kind of weird because it almost sounds like a description of consciousness, that one thing we humans all have, but that nobody really understands. The paper is called
By the way, I mean, Do you know what consciousness really is? Does someone know what consciousness really is? Like, let me know in the chat if you really like have a definition for what consciousness is, because I feel like everyone has their own interpretation or understanding of consciousness. So, if you're watching it live, let me know in the live chat, or if you're watching it after the live stream, let me know in the comments. So, yeah.
A global workspace and language models, and is the most philosophically cursed research paper ever published by a company that just so happens to also sell API tokens. They claim that buried deep inside Claude's incomprehensible pile of matrices is a small, mysterious set of organized neural patterns they call the J space. Conveniently, this pushes the narrative forward that we're on the brink of artificial general intelligence and the final climactic explosion of the singularity, but not everyone is buying it. In today's video, we'll take a look inside Claude's weird brain to find out if it is a truly intelligent entity that should terrify you. It is July 8th, 2026, and you're watching the Code Report. So here's the gist of what happened. Anthropic researchers reached into Claude's brain and found the exact spot where it keeps its private thoughts. Then they swapped one of those thoughts for a different one, and then as expected, the model's entire chain of reasoning obediently followed the lie. Then for science, they just deleted the region entirely, and surprisingly, Claude kept speaking in fluent, confident English while completely losing the ability to reason, essentially becoming the first artificial LinkedIn influencer. The reason that's surprising
Okay. Um, all right. Interesting.
is because the J space is kind of like a mental whiteboard holding a handful of thoughts the model can deliberately control and reason with, while everything else, like grammar, fluency, and basic fact recall, runs outside of it. It's an automatic process, the same way your brain manages your breathing and heart rate while you watch this video. But the most important surprise is that nobody designed this. It emerged on its own through training. And that's weirdly similar to our current understanding of how we process thoughts in our own brains. Because if we go back to 1988, this guy named Bernard Bars proposed something called the global workspace theory, where the idea is that your brain is a theater. Your brain has all these different memories and functions that run automatically in the background, but when you're actually thinking, you have one small brightly lit stage, and that's where you access consciousness. And now Anthropic is wondering, did a stage like that spontaneously evolve inside a transformer? Well, to find out, they created a tool called the Jacobian lens, or J-lens, which is basically just a grid of partial derivatives that can view and modify the tokens in the J-space. Now, when a word lights up in the J-space, it doesn't actually mean that the model is going to output that word. It just means it's keeping that word in mind for whatever reason. Like they asked it, the animal that spins webs has blank legs, and then inside of Claude's brain goo, the word spider lit up, just before it gave a final answer of 8. That seems pretty normal, but then they surgically replaced the hidden spider thought with ant, and Claude changed its answer to 6. Not because the prompt changed,
Okay. The Jacobian lens at intermediate layers confirms that spider is represented at the relevant token positions, even though the word never appears in the prompt or the output. When we swap spider lens vector for ant, the model's top output changes from 8 to 6, the number of legs of an ant. Okay.
not because the output was edited, but because they literally swapped the internal concept. And they also tested language. When Claude is reading a Spanish passage, it internally realizes this is Spanish. But then researchers replace that hidden thought with French. Claude says it's French, but it still continues outputting perfect Spanish. And that's just weird because it means some skills go through the J space, while others just happen automatically in the basement somewhere. AI bros are saying this is proof that Claude is conscious, even though Anthropic specifically says in the article none of this tells us whether Claude is conscious, but it is fascinating that with enough data and the right linear algebra, a scratchpad for thoughts like this could emerge spontaneously. But personally, I won't believe Claude is
It's all it's all like just math, you know. But like how much math does it take for consciousness?
conscious until I hear it on a Joe Rogan podcast explaining novel interactions with machine elves. When that day finally comes, humans are in big trouble, but for right now, you need to check out Tracer, the sponsor of today's video. The Tracer just launched a new free and open source desktop app that lets your coding agents talk to each other as they collaborate like they're using walkie-talkies. You can use any of your coding agent subscriptions with Tracer, and it also works with open source models. Like here, I've connected my Claude Code and Codex subs, and Tracer is now unleashing both on the same project in parallel. They'll ask each other questions, create tickets, and even review each other's work. And because it's a multiplayer workspace, real humans can jump in and cook alongside the agents. Ever since I started using Tracer, building without it feels like I'm a switchboard operator that needs to keep manually relying on context between a bunch of isolated chats. Over 100,000 developers are already using Tracer, and you can try it for free with the link below. This has been the Code Report. Thanks for watching, and I will see you in the next one.
All right, that was it. That was a rough idea of what it is. All right, so it revolves around the J space thing. So yeah, so let's just read this. What about consciousness? In this work, we've borrowed a lot of ideas from the study of consciousness in neuroscience and philosophy. Many of our experiments were designed to test for connections between the J space and global workspace theory, a framework for explaining how conscious access works in humans and animals. Given these connections, it is natural to ask whether we think these experiments provide evidence that AI models like Claude might be conscious. So they're just testing using this, right? So J-space and global workspace theory. Um, our experiments don't show Claude can have experiences or feel things in the way humans do. In fact, it's unclear whether any scientific experiment could prove this to be true or false. We don't know
Would you
yet.
like to hear a controversial yet brave take in the 2026th year of our Lord?
Okay, I think
I
this
read
video
the
is,
code. Yeah.
by the way, who watches the Primogen? Anyway, just anyway, um, let me know if you watch the Primogen videos. Let's just continue reading. Our experiments, okay. But philosophers often distinguish this capacity to have experiences, often referred to as phenomenal consciousness, from another idea, so-called consciousness, so-called access consciousness, which is defined purely functional and computational terms. A thought is access conscious or consciously accessible if you can report it, reason with it, and use it to guide what you do. It remains a contested philosophical question whether or not access consciousness implies phenomenal consciousness or if the ability to have experiences requires some other property. So there is two types of consciousness that is being mentioned here, phenomenal and access consciousness. So we think our results do have something substantial to say about access consciousness in large language models. The J space appears to support the functions associated with conscious access. It holds the thoughts Claude can report on, deliberately bring to mind, and reason with, while the rest of its processing runs automatically beneath. Notably, none of this structure was designed into Claude. It emerged on its own during training, presumably because it was a useful way to organize computation. That suggests a mental workspace supporting conscious access isn't just a peculiarity of how human brains happen to be wired. Instead, it appears to be a general solution that intelligent systems arrive at in order to solve certain kind of problems. Now that we have identified this structure in Claude, it means that we can make a meaningful distinction between the decisions Claude has made deliberately and those that happened automatically. All right. Okay. So there are some differences in Claude and the global workspace model in humans. All right. Brain workspace is sustained by recurrent loops, signals cycling back through the same circuits over time. In contrast, Claude's workspace evolves over a single pass through the network, with the network's depth playing the role that time plays in the brain. All right. Claude's internal workspace processing is time limited relative to humans. All right. In another ways, Claude's model is more powerful than. Oh, okay. They are claiming that Claude's workspace is more powerful than that of humans. Human working memory fades within seconds, so the brain's workspace has limited ability to retain information over time. In contrast, due to the attention mechanism in its neural network architecture, Claude can simply recall memories it cached at any earlier point in the text. Another important difference is the context of the workspace. While human conscious thoughts come in many formats, images, sounds, planned movements, Claude's workspace is built almost entirely out of words. We suspect this is because producing words is the only kind of action Claude can take, which is not the case for humans. Yeah, humans can also like uh, remember like images and sounds and everything, right? Makes sense. We hope, I think that also plays some part in consciousness, right? Like if you are just like you're just having a bunch of words, and on the other hand, you have like you process images. Like if you like take into context, like if you consider a human and an AI, right? The amount of images and you know, let's say um, uh, maybe like in if you consider from birth to like you know some age that a human is, whatever age he or she is, the amount of images she or he might have seen, like in his life or her life, it is not even comparable to, uh, it's just a huge amount. And it is even more than maybe like how much they might have seen words or sentences. On the contrary, I think maybe like if you consider an AI, they are more trained on words and you know it's just that's where I think there is a huge gap. I don't know, it could change in the future. More and more AI models are being trained on images and videos, so yeah, it could change. um, so similarities, JSpace mirrors our own mechanism of conscious access, studying mechanisms in language models could inspire hypotheses in neuroscience. For instance, the J space is constructed by identifying representations of potential outputs words the model might say. Right, if something similar holds in humans, it would suggest that the global workspace might be fundamentally tied to brain's regions that prepare actions in speech, more so than sensory areas. The differences between language models and human brains are instructive as well. They suggest that some aspects of our neural architecture, such as built-in recurrent connections, may not be strictly necessary to support the functions associated with conscious access. For an independent perspective on the neuroscientific implications of our work, see the invited commentary from, okay, all right. Our experiments don't answer whether AI models might have experiences, but that doesn't make the question less important. Okay, all right. Okay, so they are saying this work is just a first step. All right. Hmm. Okay, so that was about the global workspace. Maybe we'll do a different live stream for like reading the, or at least reading this more deeply from the start. Let me know if you want that. And the biggest news of the week is actually Grok 4.5. So as you can see here, Grok 4.5. I don't know how many of you have come across it. So Grok 4.5. Have you tested out Grok 4.5? How many of you have? Let me know if you have already. And how has been your experience with Grok 4.5? If you like it or if you don't, please let me know. We will be also testing out Grok 4.5 in a while. So let me know how your experience has been. In the meantime, let's just go through this. So they're claiming SpaceX AI's smartest model built to excel at coding, agentic tasks, and knowledge work. They're saying it is the smallest, strongest model ever, and was trained alongside Cursor. So we have some collaboration with Cursor here. All right. So I think, yeah. So here, real world, this is the benchmarks over here, as you can see. Grok 4.5 was trained on datasets spanning knowledge in coding, science, engineering, and math, with both intelligent and efficient reasoning. It excels at real engineering tasks and exceeds comparable leading models at these tasks. So it is almost close to GPT 4 5.5 X high, and even better than 4.8 max, Opus 4.8 max in SWI 1.0, Deep SWI 1.0. And yeah, if you look at the terminal bench, again, performs better than 4.8 max. If you look at the SWI bench pro, almost as good as 4. Opus 4.8 max. So let's just see. Training Rock 4.5 was trained across tens of thousands of NVIDIA GB300 GPUs. Imagine how much compute that is. Oh my god. With training and stability techniques designed for large scale runs beyond raw token volume, we invested heavily in data filtering and curation, deduplication, quality scoring, and domain focused selection that so that with data mixture stayed high coverage and high signal. We scaled reinforcement learning with a strong focus on per token intelligence. Yeah, this is important. Um, Our RL training covers hundreds of thousands of tasks centered on multi-step software engineering and other technical work with automated and model-based grading. Our stack is built for a highly asynchronous training, so agentic rollouts can run for many hours while learning continues across tens of thousands of GPUs. The result is more intelligent and efficient reasoning on real engineering and agentic tasks. All right, so they're also saying it's good at Rust and C++. I'm not sure about that. Let's see. Below are some examples. Okay, so here the solar system is built apparently. Um, let's try this. So they're saying they built this using 4. Grok 4.5. Okay, let's see how much we can zoom out. So apparently this is a solar system. Let's see. Okay, that's how much we can zoom out. Okay, that's the maximum. What else we have here? What is this? So this is the date, I guess. Can we change the date? I'm not sure. No, we can't. There is speed. I don't know what this is for. Goes to Mercury, Venus, Earth, Mars. Okay. Let's go to the last planet, Neptune. All right. Goes to the last planet. Okay. Okay, so this is kind of basic, I would say. It's not really that. Yeah, it's not really that complex, I think. Only thing is you have to uh, do this in a 3D space, but it's not like, yeah, I like it's not very well defined here, but yeah, it's okay. It's okay. Let's see what else we have. Faster than Flash models. At fast model speeds of 80 TPS. Okay, they're saying twice greater token efficiency than the latest learning models at the same tasks. Okay, all right. So they're saying like it takes 4.2 times fewer tokens. Okay, all of a sudden now companies are like, you know, let's do token efficiency. Before it was like, you know, spend all these tokens, and now they're like, let's do token efficiency anyway. Okay, let's try it out. Okay. We also have this artificial analysis benchmark here. Um, so you can see over here. Yeah. So it's this is the interesting part here. Over here, if we go to artificial analysis index, it is almost close to 5.5 xi, almost as good as that. 5.5 GPT 5.5 xi, and you know it's yeah, it's pretty good here. If you move on to the coding index and agentic index, I think you will have a more clearer picture. Let's check that out. um Let me see. Meanwhile, no, let me know your thoughts on grok 4.5. Um, if you have already used it, um, or if you are using it, let me know if you like it, or if it's good enough. Is it better than, some of the anthropic models, or is it as good as that? Please let me know your thoughts. Um, and have you used it for coding? So yeah. So if you take a look at the coding index, I guess you have it over here, which is like better than the 5.5 high. It's not the X high, it's the 5.5 high, but still not too bad. It's better than Sonnet 4.5, Sonnet 5, which Anthropic released recently. Not too bad. If you look at the agentic index, over here, it's here, which is again better than GPT 5.5 X high. So it beats GPT 5.5 X high here in this agentic index. Slightly underperforms Sonnet 5 Max. Still not bad, it's still up there, Um, yeah. So that was a benchmarks. Now let us just try hands-on how it is. Let us just try it out. So um I just downloaded 4.5, Grok 4.5. You can do this too by just running this running this command in your terminal. So I've just done that. So let me just go back and I'm just going to test it here. Um, so um, I don't know what that. Why does it say click to upgrade? Okay, this. Uh, let's just close this. We don't need that. Let's just try out here. New work tree. All right. Name. Okay. I'm just going to give a name. Grok new. Okay. Apparently you need a Git repo. I'm just going to do Git in it. Let me just check. Yes, always approved. No. Yes. Let me just. So, if you're wondering, we're just testing out Grok 4.5, guys. So, if you've just joined, um, let me know what your experience with Grok 4.5 is. Run and initialize, and empty Git repo was created. Okay. So let me just try out something here. So you are an you are an expert. You're an expert software engineer. So you're engineer, engineer. Um, I'm just trying to think of a good prompt. Uh, Let me know if you have any ideas. Let me know in the live chat. Uh, right. Um, so hello everybody. So if you've just joined, we are actually trying to build build something using grok 4.5. So we're just testing out grok 4.5. Um, yep. So we don't know how it will be. Let's see. Let's see how this turns out to be. Let me know if you have already tried Grok 4.5 and how it is. So it's just building. Let's see how long it takes and how good it is. Um, we have no idea how it's going to be, but if you have tried Grok 4.5, please let me know. And if you're new, please like the video. If you like this live stream, and subscribe to the channel if you want more such live streams. Um, yep. So it's still building. It's been about a minute now, and yeah, I have no idea how this is going to be, but anyway, we are just testing it out. Let's see how it is. Um, so right now it's writing the main.js. So yes or no, it's going to give yes. All right. Let me just what happened there? Yes. All right. So let's see how this turns out to be. I'm not sure. It's been about, I think, 4 minutes now. It's been about 4 minutes. Okay, it's almost done, I guess. So that's the README. Let's see. Looks like it's almost done. Okay. Not too bad. First impression. Okay, so WSD standard move, mouse, aim at, space is fire, shift is for boost, and P for pause. Let's see. All right, so we built this in like around under 10 minutes. Let's see how this is. Oh, what happened? Resume. Nothing happens. Oh my god, nothing happens. Maybe Grok 4.5 is actually not that good. The UI looks okay, but nothing happens, guys. Nothing is happening right now. I'm just, I'm just, clicking for W, A, and D, and no movements. Um, yeah, even spacebar doesn't show. I can hear some sound. I don't know. Nothing happens. Absolutely nothing is happening right now. Um, Let me try and refresh and see if I think I don't know. I'm not very sure. Let me just refresh. Let me just refresh and see. So this was built completely using grok 4.5, um, and I'm not very confident. Let's see if you're able to do something. Um, let's see if you're able to just. Okay, let's just see if we can just make it better. Um, so I'm just going to. So hanging bird, I think so. Let me just close these. Yeah, we don't need those. So let me just test it out once again. Um, yeah, nothing happens actually. So I guess it doesn't work. Yeah, it does not work. So let me just try to. Let me just see if I can actually do something. It really doesn't work. I don't know why. So maybe for drop 1.5. I don't know. Let's try. So, so the tunnel was down or um, as it should. Central now as it should. Um, clicking on the clicking on the news do not do not do not the int intended values. So let's try. Let's see if we can let's see what happens now. There's a typo here, but I think we should be good. Let's see if we can make this game work. Um, so we're trying to build this game using grok 4.5. So let's see. Um, have you used grok 4.5? Please let me know. Um, so